Hey, my name is Christopher Parham here at Lipo Connection Solutions, and I'm doing this video to showcase this new power supply I'm making. This is two 12-volt 750-watt power supplies in parallel. They come with 4 outputs, 2 on the top, 2 on the bottom, and then they have a short wire linking both of them. They're voltage matched. They load share without an issue, and so this video will demonstrate how well it load shares. This is currently the power supply plugged up to the wall. I have 119 volts. Power factor correction is quite low right now, but it does go up once it gets put under load. 60 hertz, 20 VA, 10 watts, 0.17 amps, that's AC amps, and we're back to voltage. So we have 2 power supplies here. They're both on and everything, and the outputs are parallel. They're just going into a power strip here. So I was just going to show what the load bank, this is the load bank here, and I have load resistors and everything in this container that has water and load resistors. And one of my load resistors is for 12 volts, 0.25 ohms, and the other one is for 24 volts, 0.5 ohms. But I'm gonna unplug one of these power supplies. I'm gonna leave the top one plugged in, but unplug the bottom one. And so we're gonna go back and check those results. The number should have dropped by half. You see, like, the watts almost dropped by half. It was like 10 watts before. Now we're down to 6 watts, 0.09 amps. So I'm going to go ahead and put this load on the power supply. All right, so I have my 12 volt 0.25 ohm load on it. You see the voltage drop. The power factor correction went up to 0.99, still at 60 hertz, 582 VA, 577 watts. All right, and 5 amps from the wall. All right, so we proved that, you know, top power supply can hold its load and everything. And that should be a 45 amp load. So let me actually go ahead and plug in another load here, which is the other load, which is 24 volt 0.5 ohm. So we're going to go ahead and plug that in. Alright, so both of them are plugged in. The voltage should have went down even more. Still power factor corrected. 893 VA, 886 watts. And we hear the fan ramp up. There's an extreme load on the power supply. 892 watts from the wall. I'm just going to unplug the load. Alright, so we dropped that down to about 16 watts. The fan is ramped up, so it's not going to drop down completely. I'm going to rearrange all of this to where this meter is on one power supply to show that one power supply is taking half the load and the other power supply is taking half the load. So give me 1 minute while I swap that around. Okay, I'm back and I have everything rewired up here. Essentially, it's the same setup before, except one of the power supplies is going through the meter. I showed how much one power supply pulls with one load, and then how much it pulls with both loads. So what we're going to do now is show how much the power supply pulls with both of them connected in parallel, but we're going to monitor one power supply, and it should be half of the wattage of, you know, half the wattage of the loads, to show that both of these power supplies are load sharing as they should. So I'm going to turn this on and have 120 volts down there. And like I said, it's monitoring one power supply. Alright, so I'm going to plug in one load here. And this is the 12 volt 0.25 ohm. It should be about a 45 amp load on the power supply. And it should be only, like before, it was pulling about 5 amps on this load. It should be pulling 2.5 amps from one power supply and 2.5 amps from the other power supply. So I'm going to go ahead and plug in the load right now. Alright, we're going to go over here to the meter, see what it says. Get that out of the way. Okay, the meter shows 116 volts, 0.98 power factor correction, 59, 300 VA, 297 watts, and 2.59 amps. So I said it was going to be about 2.5 amps. So the load is almost split perfectly. I mean, we're in the margin of error. Like I said, before one power supply, it was pulling 5 amps. With two power supplies, one power supply is pulling 2.59 amps, and the other one should be pulling about the same amount. And we're going to go ahead and let's, we said it was 300 watts before. Like I said, the load should have been 590 watts to 600 watts. And so we have a 300 watt load. And so like before, it was 890 watts with both of my loads on here. So let's go ahead and plug in this second load resistor and see what the load is now. Alright, so I have the second load resistor plugged in, and we've bumped up to 460 watts on one of the, remember we're monitoring one of the power supplies, so 460 plus 460 should equal up to about, well, 463 watts. So we're going to just round it to 460. 460 plus 460 should equal about 920 some odd watts, 925 some odd watts. So we're still in the margin of error of everything. So, and like I said, this is monitoring one power supply. The other power supply should be sharing half the load. And so we're going to do something else right now. We have both of the power supplies plugged into this power strip. If I unplug one, the other one should pick up the load, and these numbers should almost double. So let's do that. Alright, so I unplugged one of the power supplies, and we see the numbers almost double. And let's go through it before it ramps up the fan. 7.85 amps from the wall, 114 volts, 0.99 power factor correction, 60 hertz, 896 VA, 891 watts from the wall. So I proved that both of these are load sharing like they're supposed to, and that it handed off the power. Like if they were load sharing, and it handed off the full load to the other power supply. So realistically, if I'm not sure how long it can hold that 890 watt load, remember that's 890 watts from the wall, the output is different. But if it's pulling that much from the wall, not sure how long it can hold it, but it handed it off. So this is truly a 12 volt 15. Is rated at 1500 watts, but like I said, it's probably going to pull about 1800 watts from the wall, roughly around, yeah, about 1800 watts fully loaded, with both of them fully loaded. I'm going to do another test here in a second to where I'm going to have my full load on this power supply with my load bank here. I'm going to have my full load, and then I'm also going to use those bottom outputs and plug up my iCharger and charge a battery with the iCharger. So not only will we have like a 900 watt load, but we'll have the iCharger going on the power supply as well, and we'll see how many amps that it can put out and what the voltage is and everything. So thanks for watching, and I'll come back with the iCharger dual load test with the load resistors and charging with the iCharger. So I'll be back in a little bit.